Hello, I'm Robert, and this time I'm going to talk a little bit about why, to astronomers, this whole idea of Nibiru just doesn't make any sense at all. It's just why it's so silly for if you've got any astronomical background. So first of all, lots of people don't really know what planets are like, and so you think that anything that's a bright light in the sky is a planet. So it would probably help a little bit if you actually have a little bit of experience of looking at planets. And it's quite easy to do. If you get a nice clear morning sometime, then Jupiter's high in the morning sky is right now just before the sun rises. So if you see a bright light in the morning sky before the sun rises, very, very bright star, that's a planet. And then if you look at it from one day to the next, it moves very slightly, but they move very, very slowly in the night sky. They don't move while you're actually watching them. So if you see something that's moving, then you know it's something closer than a planet. And so Jupiter, that's the biggest of all the planets. And if you get your binoculars out, you can see its little moons, and they change position from night to night as well. You can see them quite easily with the 7 times binoculars. And if you think about it, even the moon, which is much closer than any of the planets, and yet if you just look at the moon in the sky, you don't see it visibly moving through the sky, do you? And it does actually move. It moves against the fixed stars. I mean, it rises and sets like the sun, but if you look at it and look at the stars around it, it doesn't move through the stars, does it? So the moon does actually move, but very, very slowly. And once a month, it goes all the way around all the way through the stars and back to where it started again, in a circle against the fixed stars. So anything you see that is moving faster than the moon, obviously it's got to be closer to us than the moon, or moving extremely fast, so fast that it's bound to be it's just on saying goodbye to the solar system, and it's off on its way out again. So when you see these pictures where you actually get something visibly moving through in the video, you know for sure that's not a planet. And if it's of any visible size, it would have to be very, very close in order for it to take any size. So you see these pictures of Jupiter, and if you haven't gone out and looked at the planets with your own eyes, you might expect that when you see a planet in the sky, you see a big thing like the moon. And we actually get this hoax every year. There's this hoax saying that the Mars will suddenly appear and will be the same size as the moon in the sky. That never happens. These pictures you see, where you see the planets like a disk, then these are taken with very powerful telescopes. And even with a kind of small telescope, then you will see the planets as slightly large disks, but they're not very big. And so actually, with your naked eyes, you're not going to see you just see a tiny little star. That's all you see. And you might notice that it isn't twinkling, which is one of the things that the ancient astronomers was one of the ways they picked out the planets, and they realised there was something a bit strange about them for 2 reasons: because they're not twinkling, and because they gradually change position relative to the fixed stars. So that may help a little bit with understanding all this about why astronomers are so sure that these things that they're taking photographs of can't be planets, and so that rules out an awful lot of the things just straight away. And if you have a look at these, a lot of the ones are going to be lens flares, and it's very easy to get lens flares, especially with a cheap camera like the one I'm using for my webcam just now. But it happens even with high-end ones, and they use special hoods to try and reduce the amount of lens flare. Lens flare is just reflections happening inside the camera, and this creates little bright dots of light sometimes just next to the sun. And a lot of the photographs you see is the sun, light going into your camera, being reflected around and producing an extra spurious little bright dot. And you get lots of things happening. Lens flare is not a simple thing. You get lots of complicated reflections and refractions and stuff going inside your lens, and as you move the camera around, some of them move around a lot across the image, and some of them just stay pretty much in the same place. So some people say, look, you can see the lens flares, they're the ones moving around, and we've got Nibiru, this little bright bit there. That little bright bit that isn't moving so much is just a lens flare that isn't moving so much as the other lens flares, because they all move different speeds in different directions. because of all the complicated reflections going on. You've got lots of multiple layers inside your camera. And then, as well as that, there's a particularly confusing one, which is an offset lens reflection. And this will happen if you take a picture through a mirror, through a window, or if you have a filter on your camera that is at an angle to it, or if you have a kind of protective lens cover, which you might have if you've got a mobile phone camera and you're going out of doors. So any of those can create this offset lens reflection, which can look very realistic, because you can even zoom in on it, and it expands and gets larger, and it stays almost exactly in the same place, unless you move the camera back and forth a lot. But it does move very slightly against everything else. So, and that was the Melissa Huffman one. It's pretty conclusively, Mick West proved that was a lens reflection by stabilizing the image, and then you can see it moving against the stars, the clouds, and it's the same size as the moon, which means the same size as the sun, which is typical for these lens reflections things. So I've seen pretty clear that's what that one is. Now, other things that can get fused, and people think they're planets. And so for people looking for Nibiru, if they see any bright thing in the sky and they don't know what they are, their first guess is that it's a planet. Now, if you take an astronomer and he sees a bright thing in the sky, and his first guess, amateur or professional, is not going to be a planet, unless it's one of the known planets that he knows is there. As his or her first guess will be a lot of other different things that it could be. So if it's moving visibly and it's in the night sky and it moves in a steady rate across the sky, it's a satellite. And if it's obviously, well, most of us know what planes look like at night, so that's not a possibility. If it's round and quite visible size and it's sort of high up in the sky, then that might be a weather satellite, not weather balloon. So scientists send those up, and some of them are this kind of teardrop shape, and some of them are just completely spherical. So it could look quite mysterious being lit up in the sky, and so that's another possibility. And it could be one of the children's balloons. So if you've seen those, you might think, how could I possibly think that a children's balloon floating up in the sky? But if you've never seen, you know, the ones that are mylar covered, very shiny, as reflective balloons. And then if a child lets that go and it goes up in the sky, and then even if it's just 100 meters up and it can go much higher than that, then and it catches the light, then that could look quite mysterious, and it's very hard to tell how far away something is. And another thing that could be mistaken for a planet is, if you don't know what a planet looks like, is perhaps a comet. Now, daytime, you sometimes get daytime comets. Now, there is one that it's not quite daytime, but it's very, very faint. You would only just see it as a very, very faint star. So I don't think any of these are actually comets at the moment, except for one photograph that was taken from the upper atmosphere from a weather balloon, and then that did seem to show this comet Catalina. It's possibly that's what that one is. But from the ground, looking upward, you're just going to see a very, very faint star. You're not going to, if you see it at all, you're not going to remark on it and think it's a comet. But if an amateur astronomer or professional saw something bright in the sky and it was extended, that would be their next guess. Or if it's not local, would be that it's a comet. And the way they actually originally proved that comets, it used to be thought that comets were in the upper atmosphere, and just very high up in the upper atmosphere. But it was proved when astronomers saw comets in different countries in the same position against the night sky, against the fixed stars. So if you want to be sure that something isn't close by, but is actually far away in space, that's what you do. So, I mean, if you can get a friend, and you can make up a friend who happens to be 10 miles further away the better, if you think it really is something in space. And ring up your friend and say, go and look in the sky. I can see something bright, and it's just next to the moon, or it's close by the sun, or it's in the middle of the constellation Orion or whatever. And can you see it? And where's the look from you? And if they say, yes, it's about 1 moon diameter away from the moon, and it's just to the west of it, and that's exactly where you see it, then that's a very strong hint that it's actually up in space and not close by. because if it was close by, they would see it. If they saw it at all, they would see it sort of above you, so in your direction, and a different place from where you see it. And that's how comets proved to actually be in outer space. So you can tell if something is in outer space, but you can't tell it just looking from one location, because our eyes, they're not far enough apart to get enough parallax to be able to see this. We can see this with very close things. I can see that that's close by and that's further away. So I can tell with things like that that's obviously closer than that, and I can tell that this is near my nose and it's not that distance away. But if you have something even half a mile away or something, and the atmosphere goes up quite a few miles up into the sky, and something could easily be a very high cloud, for instance, and there's absolutely no way, and even things that are quite close. It depends on your eyes. Some people are better than others at this. In my case, my eyes are a little bit wonky, and I find it difficult to tell the difference between a buzzard and an eagle, because I can't tell how far away they are when they're flying up in the sky. So an eagle is much larger, so if you can tell how far away it is and the visual diameter, then you can tell between the two. So my sister can tell them apart easily just by the size. So some people are better at telling that, but you have to get your eyes in for it as well. So some people can tell whether it's even at quite a distance how far away something is, but if you get some miles away, you won't even be able to do that. Not with just your two eyes. And so the first guess is always going to be that it's in the atmosphere, because there just aren't that many celestial objects out there, and we know where they are, except if it's on one of the known planets. And right, so now what else do we talk about? Okay, so now so that's about the observations, and then how you can tell whether it's likely to be whether it's nearby or far away. And the default assumption is always going to be check that it's your camera, and check if it's things like clouds. Oh yes, I didn't talk about the clouds. So in many parts of the world, I get the impression that clouds are complicated, that you get just blue skies and then sometimes a few wisps of clouds in it, maybe you get overcast sky, but you don't get very complicated cloud phenomena. And then suddenly you might get an unusual situation where you see different layers of clouds and bright lights forming in them. Now where I live, on the west coast of Scotland, we get very complicated skies, and it's nearly always cloudy, and those are very rare that we get, except in summer. Sometimes we get entirely blue skies, but it's very rare. Generally there's lots of clouds. And then, so we get lots of experience of seeing how the sun shines through the clouds, and you get all sorts of different types of clouds. You have the cirrus clouds, which are very high. You have the cumulonimbus. You have the big clouds that you're probably used to on a sunny day. You get the stratus clouds, which are kind of layers, thin layers. You get, I forget the name, the mackerel sky, the ones with lots of little dots all over the sky. The sort of speckled dots all over the sky. That's another kind of cloud. And you get little turrets, things coming up, and the light can shine on those. You get little bright lights here and there, and all sorts of complicated shapes of light. And especially at sunset, as the sun is setting before it sets, you'll get lights all over the sky, all sorts of different bright lights here and there across the sky. So I think a lot of these photos that I've seen, they say, oh, this looks like Nibiru. We've never seen anything like this before. I think that's just an ordinary sky. I assume we get them all the time over here. So do look out for that as well. And right, so that's about these so-called observations of Nibiru, and people have been showing them on the debunking page, and apart from some obvious hoaxes. So someone has just posted this video. This is supposed to be a video of an unknown moon above the North Pole, which is shown as being a huge thing, even bigger than our moon, visually in the sky. And they have the idea that it's only visible from the North Pole. And now you could have something that's only visible from the North Pole, true. But first of all, realise that the North Pole is like a sheet of ice. That you don't have big telescopes there, you don't have a base there. You have to go on a polar expedition to go there, because there's no solid land there. And then, if there was something only visible from the North Pole, that would mean it's in the atmosphere above the North Pole. And it would just have to be actually hovering above the North Pole. And that's just, unless it's some big inflated moon that someone has sort of put up like a balloon above the North Pole, and even then it's not going to stay there long, it's got to get blown away by the winds. So that's the only way you can have something above the North Pole, and if it was really big, you'd see it from space. In the photographs of the North Pole taken from space, then you see this great big spherical thing above the North Pole, just sort of floating in the atmosphere there. If it's any higher than that, you'll see it from any of the northern latitudes, and if it's about distance of the moon or something, you see it from pretty much the entire northern hemisphere. But as well as that, if something is above the North Pole and it's actually not in the atmosphere and floating in the atmosphere, then it would be falling, and it would hit the North Pole before long. If it's just hovering above the North Pole, because there's nothing to keep it up there. People have this misconception that when you go above the atmosphere, then it's zero G and things just float. But that's not true. The International Space Station is in free fall. So it's like if you throw a ball and you throw it faster, it'll go further before it hits the ground. If you throw it fast enough, the Earth actually curves away. And so as it falls down, even though it keeps curving down, the Earth falls away, the curve of the Earth falls away faster than the thing can fall down. So then it's in orbit. And that's how the ISS is in orbit. And so it's actually falling all the time, and the astronauts inside are falling at the same speed, and then that's why the astronauts float around inside. It's basically like if you're in a lift, and then if someone cut the cable, then you'd be floating around inside the lift, because you fall at the same speed as the lift. So if you had a big heavy object floating above the North Pole, and it isn't floating on the atmosphere, it would fall and hit the North Pole. So the only way it could be above there and not do that is if it's in orbit. And if it's in orbit and it's above the North Pole, then it's in an orbit that also goes around the South Pole, and goes round and round and round like that. Now, that can happen. We have artificial satellites, but actually that can happen with real satellites. So in 2007, astronomers found a satellite that's only 5 meters across that did exactly that. Now, they only found it with very, very sensitive telescopes. You couldn't see it with your naked eye. It was further away than the moon most of the time. It was in a 3-month orbit that went above the North Pole and above the South Pole every 3 months. So every 1.5 months it was above the North Pole, 1.5 months later it was above the South Pole. It was a very long orbit because it was further away than the moon most of the time. So you can get moons that are some of the time above the North Pole but a very, very long way away. There was a temporary moon, and it did, I think, 3 or 4 orbits, and then it went away off around the solar system again. So this happens from time to time. And they think it's actually, although we can't detect them, at any particular time there's at least a 1 meter moon up there, probably quite a few of them, beyond our moon, probably, in these big temporary orbits around the Earth, before they go sailing off into the solar system again. So that can happen, but this thing, whatever they photographed they took off, it obviously wasn't that. It was something big, visibly big, much bigger than the moon. And if you look at it, I mean, I think it's an obvious fake. It looked to me like a very badly done sci-fi movie. Back in the 1970s, they used to do these matte paintings of scenes, and then the characters would walk back in front of it, like Doctor Who and things like that. If they were on an alien planet, they would have a painter would paint the scenery for the actors to act in front of, and that's what this looked like to me. It was just a painting of a moon, of an alien moon, with the camera in front, wobbling around in front of the painting, and there was a fade from a picture of an icy landscape with a flag on it, then went over to, and then faded in. I don't even know if it was the North Pole, that faded into this picture of the moon with a kind of painting with the kind of somewhat similar, very similar kind of colouring. It looked like an obvious fake to me. So you do get fakes as well, for sure. Just starting out fake videos. Anyway, so now I'm just going to talk a little bit about the orbits and how we can be so sure that you can't get an orbit around the why it can't be hide it behind the sun, then suddenly jump out and hit the Earth. So if you can look at the sun, we've got these telescopes like the SOHO telescope that is constantly looking at the sun, And the best one to look at is the wide view one, and you can get a grandstand view, and you see planets. I've just been watching Mercury. It slowly went across the field of view, and it's just gone out of it. So you do see planets there, and Mercury is the closest planet to the Sun. So I suppose that's probably the most likely one to see there. It's gone out of the view now there, so you can't see it anymore. The planets look like a bright star with a horizontal line through them, which is some kind of lens flare thing. And then you get comets there from time to time. There doesn't seem anything very much there just at the moment. Anyway, so you can look at the area around the Sun. If there was a hidden planet in there, you'd see it moving around, as well as Mercury, which you already do see there, and Venus, and we'll see other planets going past the Sun whenever they're in that region of the sky. Well, you'd see this extra planet as well. You see it going around, and if it's in a closer orbit than Mercury, then it would still be there. I'd be very frequently going past the Sun, just going back and forth all the time. The only way it could not be visible in that image is if it was actually inside the occulting disk, behind the occulting disk in the middle, which would mean you'd have a very fast orbit, or maybe a few days or something like that. Then you go and look at the other images, and you'd see it as a big black dot moving across the Sun. Every time it crossed over, you see this very obvious. Doesn't look like a sunspot. It would be a perfect circle. That would be very obvious if there was a planet in there crossing the Sun every few days. And just like you can't have a moon hovering above the pole, the North Pole, you can't have a planet hovering the other side of the Sun, close to the Sun. It would fall into it. Because it could only go around, in order to always be the opposite side of the Sun from us, it would have to go around the Sun once a year. That's not nearly fast enough to keep it above the Sun, and it would fall into it, just like the moons I was describing above the North Pole. So it can't hide the other side of the Sun, so it has to keep coming around to this side in order to not fall into the Sun. So if there was something there, it'd be very easy to see, and with the instruments that we have available to us. And it's not just, these space telescopes are the best in some ways for looking at the Sun, but we also can do it from the ground as well. They're specially designed telescopes designed for looking at the Sun from the ground as well, and we'd see them in those as well. Your average telescope, you shouldn't point to the Sun because it would damage the optics, but you can design telescopes, you can put filters in front in order to filter out the Sun, and you can design, they're specially designed, huge telescopes designed just for looking at the Sun on the ground, terrestrial ones, just as they are for looking at stars. And so if there was a planet, and we have looked very carefully at this, we've actually tried to find a planet in between Mercury and the Sun. That started in the 19th century. It was called Vulcan back then. They actually had these perturbations in Mercury's orbit, which got the people then very intrigued because Newton's gravity didn't explain Mercury's orbit around the Sun. And so it was actually it was in slightly the wrong position. And quite recently, then they actually, Leverrier, the French astronomer, he'd recently discovered Neptune by that method, looking at the perturbations of Uranus and of Uranus. And so they were all thinking, well, we found this distant moon, Neptune, way out there. Then maybe we'll find another moon, planet. Maybe we'll find another planet in between Mercury and the Sun. And they got they actually got some observations that they thought were this Vulcan, but they were probably just sunspots. Because especially with telescopes they had in those days, it wasn't so easy to distinguish. Nowadays it would be very obvious. But so anyway, they had a few sporadic observations, but eventually they discovered there really wasn't anything there. And then finally that was explained. That was a big mystery until Einstein came along with his general relativity, and along with explaining quite a number of other things, he explained that the gravity is just very slightly different from Newton's gravity, just enough to explain Mercury's perturbations. And so then this idea that there could be a Vulcan went away because everything was explained. And in fact, it disproved that there couldn't be a big planet in there anymore because it would change the position of Mercury away from the general relativity theory explanation of how it should move. So after that, they knew that there couldn't be a big planet in there. And there could be a tiny, tiny one, and these are called the Vulcanoids. And the largest they can now be, we've actually been searching for those as well. And that is a more recent search with our powerful telescopes we have now. and they haven't found any, because there's a place between Mercury and the Sun. If it's too close to the Sun, it'll evaporate, because the Sun is very, very hot. That's not the problem. If Nibiru went as close as that, then it would evaporate in the heat of the Sun. Even an entire planet would evaporate if it was that close. So, well, it would evaporate slowly, but certainly these small ones would evaporate. These, with this Nibiru, they have the idea that there actually are intelligent creatures on there. So that's another point about it being as close to the Sun as that. If it was really so close to the Sun we couldn't see it, it wouldn't just be the seas boiling. The rock would be molten. The entire rocky surface of the planet would be molten if it was as close as that, and it would be evaporating up into space. And if it spent a lot of time there, the whole thing would certainly get a lot smaller anyway. I'm sitting there because I haven't actually looked up how long it takes for an Earth-sized planet to evaporate if it is close to the Sun. But certainly a small one, like a few 60 kilometers or so, that evaporated quite quickly. So there was this inner limit that if it was too close to the Sun, it would evaporate away. If it was too far from the Sun, it would get perturbed by Mercury. There's a little space in there, a little wiggle room, where there could be asteroids to this day. And these are called the Vulcanoids. And people have been searching for these asteroids, but they haven't found any. And the limit is that it can't be bigger than, I think they say, 60 kilometers, or we would have found them by now. So this is it's like in our backyard. It's like saying you're missing there's a big oak tree in your backyard. You would know it if it was there. There's no way that we could be missing a big planet close to the Sun. We can easily miss them around other stars. And that's like saying there's an oak tree somewhere in Glasgow. Lots of oak trees in Glasgow I don't know about. That's several hundred miles away. But I couldn't possibly be missing an oak tree in my garden. So it's like that. There could easily be planets around other stars, and we're actually finding them. And then they're sort of tens of light years, many light years away. The nearest one is it 4 light years away? Something I have to look that up as well. But they're many light years away. That's a long, long distance away. The Sun is 8 light minutes away. So that's the time it would take a light to travel in 8 minutes. The nearest star is several light years away, so it would take light several years to get the nearest stars. So the missing planets out there, for sure. We're finding lots of them. And then there's possibility of finding small planets beyond Pluto. And then the further away you go, the larger they can be and still be hidden. The closer they are, then it's almost impossible for them to be hidden. So inside of the Jupiter orbit, our telescopes are so good that we now know all of the ones of the size of New York, 10 kilometers or so, inside of Jupiter. And so if there's something that was of that size that's not seen, it's beyond Jupiter at the moment. And then maybe it's going to come into the inner solar system later. So we couldn't be missing Nibiru. We've got big telescopes doing full sky surveys. And so, that then gets back to this idea. So first of all, we couldn't be missing it around the Sun because we do look there very closely nowadays. And we couldn't be missing it anywhere else. It would be very obvious as well. And then they have this idea that's in a 3,600 year orbit. That's what these people tell us about Nibiru. They're just coming out of their imagination. There's no astronomical journal that says that. It's just these people saying they've been contacted by extraterrestrials, or they've been reading ancient Sumerian texts, and they have come to the conclusion that there must be a planet with a 3,600 year orbit, and it's habitable even though it goes from frozen nitrogen temperatures to temperatures so hot that the rock would boil, and it's got people like us living on it, and somehow, it's a very silly assumption, I must say. And so anyway, if it was in this 3,600 year orbit, then it spent 1,800 years getting from beyond Pluto to the Earth. And so they have this idea that, how could we possibly miss a planet? It gets to the Sun, which is the hardest place for it to see in the solar system, but to get there, it's gone from beyond Pluto. It's come in past the Jupiter orbit, and they say, oh well, it was hidden behind a gas cloud, and that's why we couldn't see it. There's a big gas cloud travelling with it, and that's hiding it. Well, that is true in the depths of space, that if that you have things like Horsehead Nebula, big black cloud that hides things behind it, that's because there are no stars anywhere near it. If you go and look at places in space where there are stars anywhere near, like the Orion Nebula, the birthplace of young stars, it's lit up like a firework display. Well, I mean, it wouldn't be that bright to our eyes, but to sensitive cameras, it's very bright. And if we have the experience of something similar in our solar system, so whenever you get a comet is just 10 kilometers or so of ice, maybe a bit bigger, and then as it comes into the sun, the ice is not just ordinary water ice, but also icy and frozen nitrogen, carbon dioxide and stuff like that, which is in its icy form. Then it evaporates, and then there's dust and things, and lots of dusty stuff as well. Well, this then creates the comet's tail, which becomes very, very bright, even though it's extremely thin. It's nowhere near thick enough to hide other planets or anything. And yet it is very, very bright in the solar system. That's because it's near to the sun, and the sun is bright. And because the sun is so bright, it lights up gas clouds and dust clouds. Because a comet basically is a very small dust and gas cloud. And that's why they're so bright. So this planet can't be hidden behind a dust cloud, because it would be like it's got a big comet tail. It would be much brighter if it's got a dust cloud in between it and us than it would be if it isn't. And then they also say that this planet, it's a brown dwarf, and they have this idea that brown dwarfs are invisible. Well, a brown dwarf is a failed star. So if you take Jupiter, now it just so happens that as things get larger and larger, when they get to Jupiter, Jupiter's about as big as it gets before it becomes a star. As you keep increasing mass to it, it gets heavier, but it doesn't get much bigger. And so if you get a planet the size of Jupiter and it gets larger and heavier, it doesn't get much larger. That is what a brown dwarf is. If it gets heavy enough, it gets so heavy, you get a little bit of nuclear fusion going on, which kind of heats it up inside, and it can get quite hot. Now, that kind of failed star, that's what a brown dwarf is. Then if it's in distances of space, it's nowhere near any other stars. It's very hard to spot, because it's not producing any light. It's not shining like a star. But if you were to put Jupiter out there, it would be even harder to spot, because Jupiter isn't even as hot as a brown dwarf. It's got a little bit of its interior warmth, but it's half warmed by the sun and half warmed by its interior warmth that is just kept from when it formed. A brown dwarf would be rather warmer than Jupiter, but in other respects very similar. The reason we can see Jupiter, of course, is because it's so close to the very bright sun. And that is absolutely true of a brown dwarf as well. So a brown dwarf would be very easy to see. Now, it mightn't be quite as bright as Jupiter, because some brown dwarfs are quite dark. But you can see dark things in the sky. The moon is as dark as worn asphalt. The moon is very, very dark, except it's so brightly lit. You know, when the astronauts were walking on the moon, you know how bright the sunlight was, because there are no clouds, there's no atmosphere. And so, although it's very, very dark surface, it's lit by the sun, and that's why it's so bright in the sky. And so even if you had a brown dwarf, which was as dark as the moon, which is very, very dark material, then it would still be very, very bright. And you wouldn't be able to miss it. The Jupiter is by far the brightest of the largest of the planets. And if you had a brown dwarf, even a little bit larger than Jupiter, and even if it was almost black as coal, you'd still be able to see it easily. And same with the black hole, we would have an accretion disk. Their ideas of how it could be invisibly coming in to the inner solar system don't work. So Galileo would have been following it, and he'd have said, "Oh, there's this thing that's been coming in, and I saw it there, and then I saw it there, and then I saw it there, and then I saw it there." We'd have observations at least back to him. We'd have it, but I think it would have been naked eye. If it's from a 1,800 year pass in towards the inner solar system, it would be one of the naked eye planets. It would have been more visible by the Neptune by the time it got into. I thought, maybe. I'm not quite sure about that. It would be easily visible by telescopes anyway. Certainly by the time they were observing Neptune in the 19th century, we'd have been tracing it in on its path into the inner solar system. And I'm not quite sure how long it would take to get from the Neptune orbit to the Sun. Come to think of it, it was on this very long 3,600 year orbit, and most of the time it's way, way beyond Pluto. And as it comes in, and then, I think maybe even, maybe even it would have been in the, I'd have to look this up. But I think maybe we'd been approaching from beyond Neptune for a century or so. But we'd have been tracing it in on this this orbit all the way in. It would taken decades to centuries to come in from when it's from beyond Neptune, and then towards Jupiter, and then it would come past Mars, and then they say it's going behind the Sun, so presumably it came past, went past across the Earth's orbit, Venus, and behind the Sun, and so you've seen it all the way in anyway, and. So basically these people, they don't have an idea of how these orbits work. Now another problem with a planet that's going back and forth like that all the time, on 3,600 year orbit, and people have pointed out that if it went as far away as they think it did, and came all the way to the Sun, it would almost been just going back and forth, almost like a straight line, back and forth. It would be a very, very elliptical orbit. And on that orbit, as it came in towards the Sun, then it would go past Jupiter's very strong gravity. Jupiter has a very large gravitational effect. Now from time to time it would miss Jupiter, perhaps Jupiter's on the opposite side as it comes past. But before it's done many of those orbits, then it's going to interact with Jupiter, and Jupiter is going to either eject it from the solar system, send it into the Sun, send it to crash into Jupiter, or tear it up into lots of little pieces. And we can see that Jupiter does that because if we look at the inner solar system, then then there are no big impacts on any of the planets in the inner solar system. Nothing. The big craters on the Moon, they're from billions of years ago. So we don't have big things like that coming into the inner solar system anymore, and that seems to be because the material that comes from beyond Jupiter. Even if you have something quite big, like getting on the size of Pluto, if that came past Jupiter, it would get broken up into lots of little pieces. So Nibiru, if there was a planet like that ever in the past, who knows, maybe there was way back in the early solar system, there might have been lots of debris around. Who knows if there even might have been a planet like Nibiru way back then, say 3 or 4 billion years ago. And going back and forth like that, it would have soon have got broken up by Jupiter. It's just not a stable orbit. So the idea is, there's just so many ways that it just doesn't work, but this idea that you can have beings living on this thing that goes way beyond Pluto and then comes in so close to the Sun that the rock would be boiling, and then they try and fix that sometimes by saying that it's orbiting a star, so it is orbiting a star way out there, so then that just makes things worse. I mean, how could we miss an entire star coming into the inner solar system, and how can a star hide behind the Sun and have a planet around it, and we just don't see it, and it's you're orbiting the Sun every few days, and then it's so hot that its planets would be boiling as well, and its planets anyway, there wouldn't be much room for the planets between this star and the Sun, and they get torn off by our Sun. I mean, that just makes it worse, really. So it's basically fairy tale kind of astronomy. It doesn't make any sense at all as astronomy as we understand it. And generally, when I read one of these so-called articles, or any of these, if I watch some of these videos or something, after about 2 or 3 sentences, then you can see that it's just bullshit, which is quite a recent polite word in the UK. It's not, but you could also call it humbug if you find bullshit a little bit too sweary in your part of the world. You could just say it's humbug. So yes, there's a nice quote that I put on in the comments. There's some chap say a Princeton philosophy article about bullshit and what it actually is philosophically, and he says that it's stuff that is neither true nor it's a lie. So in order to lie, you have to have something that you know is true that you're lying about. So I don't think these people are lying because they don't understand enough astronomy to lie. They simply don't have enough understanding of astronomy to say something that's false because they don't know the truth. And they're not telling the truth because it's not astronomy. So it's this kind of in-between thing, humbug or bullshit, where they're just talking about something you don't understand and just producing lots and lots of nonsense. So it's neither true nor is it false. It's just, it's false in the, you can say it's false in the sense that there isn't any Nibiru out there, but it's false also in the sense that bullshit and humbug is, that it doesn't actually make sense. You can't refute it because it doesn't actually make sense. There's nothing there to refute. It doesn't hang together. It doesn't work as astronomy. And I've done my best to explain why that is. If any of you still think it makes sense after listening to this, well, it'd be good to learn a little bit of astronomy, really. Try observing the planets and try and learn a little bit about orbits and things, and maybe you can come to see this. And then the other thing is what I talked about, rational trust, and that how you can look at the way that people use citations. So even if you can't understand the astronomy and you can't kind of test that for yourself, just look and see if these people are telling the truth about other things that you can test. So they say things like that Robert Harrington has been murdered. You go and look and you find his obituary where he said he died of throat cancer, and you go through all the things you can test, lots of things you can test, and they just get them wrong one after another after another. So then you can work from your own reason, even though you don't know any astronomy. You can work out that this is humbug or bullshit that they're doing, because they're not even bothering to check, or they're not trying to make what they say consistent with what they've read. They're just coming out of their imagination, a whole flow of this nonsense. Anyway, that's the best I can do, and so I hopefully that helps you a little bit. That some of you are getting scared about this stuff, and hopefully I just give you a little bit of a flavour as to why astronomers just think it's such unutterable garbage and humbug. And if you have any questions, do say, and thanks very much.